Hey everyone, and welcome to This Explainer. Okay, so have you ever just stopped and wondered how we take the massive scale of an entire planet and somehow shrink it down to pinpoint our exact, precise location? Today, we're demystifying the brilliant systems humanity has created to navigate our globe.
Here's our roadmap for today. We're going to cover 1. Mapping our world. 2. 3 types of maps. 3. The map toolkit. 4. Globes, the true model. And finally, 5. The global grid system. Let's get into it.
But before we get into the nitty-gritty of maps, I want to set the stage with something incredible. Listen to this quote from the ancient Indian astronomer Aryabhata. He said, "The globe of the Earth stands in space made up of water, earth, fire, and air, and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic." It is just amazing to think that long before satellites and digital GPS, early scholars already understood our Earth as this floating, spherical home to all life.
All right, moving into section 1, mapping our world.
Picture this. You just stepped off a train in a completely new, unfamiliar city. You're standing there at the station. How on earth do you find the bank, your hotel, or maybe a famous monument like the Taj Mahal? You could ask a local for sure, but a map? Well, a map is basically a brilliant pocket-sized treasure guide. It solves that ancient problem of getting lost by showing you exactly where things are.
So, what actually is a map? At its core, it's just a flat representation, a drawing of a specific area viewed from the top down. Imagine you're a bird looking straight down at the ground. It can be of a tiny village, or it can be of the entire world. And when you grab a whole bunch of these maps and bind them together into a single book, well, that's what we call an atlas.
Which brings us to section 2, 3 types of maps. You see, depending on what you're actually looking for, you're going to need a different kind of guide. First up, we have physical maps. These are all about nature. If you're looking for rivers, mountains, or deep oceans, this is your map. Second, political maps. Because, nature didn't draw borders, humans did. These show countries, states, cities, and the boundaries between them. And finally, thematic maps. These laser focus on one very specific theme. Want to know where all the national parks are, or which areas get the most rainfall? You'd pull out a thematic map.
Okay, let's dive into section 3, the map toolkit. To actually use any of these maps, you need to understand the language they speak. And it comes down to 3 basic tools. Step 1 is distance, using a scale. Step 2 is direction, finding north, south, east, and west. And step 3 is symbols, those little signs for real-world features. These 3 steps are literally all you need to read any map in the world. Think about it for a second. How do you fit an entire massive country like India or the whole world onto a single piece of paper? The secret is scale. Scale is just the ratio between the actual distance on the ground and the distance shown on your map. It's kind of like magic, letting map makers shrink thousands of kilometers into just a few manageable centimeters. And this brilliantly illustrates why maps look so completely different depending on what they're showing. If you're looking at a small-scale map, like a map of the world, 1 centimeter on your paper might equal 500 kilometers on the ground. So it shows a huge area, but you don't get a lot of detail. But a large-scale map, that's used for smaller areas, like your local town. There, 1 centimeter might just be 500 meters. Because the area is smaller, you get way more detail, down to individual streets and buildings. Right, so once you know the distance, you've got to know which way to walk. Maps use our 4 major cardinal directions: north, south, east, and west. Usually, you'll spot a handy arrow pointing up with an N for north. Once you've got north, you can figure out the rest. We also use intermediate directions, like northeast or southwest, which give us even more precision. And hey, if you're ever out in the real world without your smartphone, a magnetic compass is a total lifesaver. Its needle will always faithfully point north-south. And finally, symbols. If mapmakers tried to draw tiny, highly detailed pictures of every single hospital, school, and tree, the map would be a cluttered, unreadable mess. Instead, organizations like the Survey of India use standardized symbols. A blue patch universally means water. PO means post office. A black dot is a well. Once you learn this simple visual alphabet, you can read the landscape of literally any map instantly. Now, as incredibly useful as flat maps are, let's look at their limitations in section 4, Globes, the true model. Here's a fun way to think about it. Imagine taking an orange, peeling it, and then trying to smash that peel perfectly flat onto a table. What happens? It tears, it stretches, and it completely distorts. The exact same thing happens when we try to flatten our spherical Earth onto a 2D map.
the shapes and sizes of the continents inevitably get distorted. That is why a globe is the truest model. It's a miniature spherical representation that shows countries and oceans in their correct proportional sizes. And it even spins on an axis just like a top, perfectly mimicking our actual planet. So, how do we pinpoint our exact location on this massive sphere? Time for Section 5, the Global Grid System.
To find our way around the globe, geographers created two sets of imaginary lines. First up, latitudes. Think of these like the rungs of a ladder, horizontal lines running east to west. They are perfectly parallel, meaning they never touch, and the circles get smaller and smaller as you move up to the poles. Then we have longitudes. These are vertical lines running north to south. A great way to picture longitudes is to think of the vertical lines on a muskmelon. Unlike latitudes, longitudes are all the exact same length, and they all pinch together and meet perfectly at the north and south poles. Let's zoom in on those horizontal lines for a second. The absolute most crucial latitude is the equator, sitting right at 0 degrees. It wraps around the thickest part of the Earth, slicing our planet perfectly into the northern and southern hemispheres. From there, we've got other vital anchor points, like the Tropic of Cancer in the north and the Tropic of Capricorn in the south, which really help define the major climate zones of our planet.
Now, just like the equator is our starting point for horizontal lines, we need a starting point for our vertical lines too. Enter the prime meridian, representing 0 degrees longitude. By international agreement, this imaginary line runs right through an observatory in Greenwich near London. And just as the equator divides north and south, the prime meridian perfectly divides the Earth into the eastern and western hemispheres. Okay, here's a really fascinating fact about longitudes. They don't just tell us where we are, they actually tell us when we are. Our Earth rotates a full 360 degrees on its axis every 24 hours. If you do the math, 360 divided by 24 equals 15. This means that for every 15 degrees of longitude you travel across the globe, exactly 1 hour of time passes. This right here is the entire foundation for our global time zones. Pretty cool, right?
So, bringing it all together, when you lay those horizontal latitudes over those vertical longitudes, they cross over each other and create this massive net around the globe. This is the grid system. Because of this grid, literally every single place on Earth has a specific set of coordinates, an intersection of one latitude and one longitude. It acts as the ultimate X marks the spot for global navigation, letting us precisely locate a ship in the middle of the ocean or a tiny remote village in the mountains. We've covered a ton of ground today, from everyday street maps to the mathematical grid that wraps our entire planet. So I want to leave you with a quick challenge to test out your new geographical toolkit. Take a second today to look up the exact latitude and longitude coordinates of your own hometown. Where exactly do you sit on this giant spinning grid? Thanks so much for joining me for this explainer. Keep exploring, and I'll catch you next time.